In this lesson, we're going to work on solving inequalities using multiplication or division. And again, these are just one-step inequalities. You'll have to multiply, you'll have to divide, just one step. Just like we saw when we were solving equations, if we have something of the form t divided by 4 equals 5, we saw that if you want to cancel out division, you have to pair it with multiplication. T times 4 times 4, multiplication and division cancel each other out as inverses, they undo each other, leading us to our answer of t equals 20. Well, it's similar here. If we want to cancel out or undo dividing by 4, we would have to multiply by 4 on both sides of our inequality. Multiplying and dividing as inverses still undo each other. 5 times 4 is still 20. And since we multiplied by a positive number, our greater than symbol will stay a greater than symbol. There's our answer. Since our directions did not ask us to graph the answer, we don't have to. We're simply done with t is greater than 20. That's all that we needed. Similarly, here we have a problem that's virtually identical. T divided by negative 4 is greater than positive 5. Just like before, if we want to undo dividing, we have to multiply. Just like before, they cancel. 5 times negative 4 would give us negative 20. But here's one really important characteristic. The one thing that you always have to be careful about when you're solving inequalities, where it's a less than or a greater than, anytime that you move over a negative, we multiplied by a negative 4. If you multiply or divide by a negative, it actually has an effect on the direction of the inequality. It flips it. Instead of having t is greater than 5, it gets flipped so that it's actually t is less than 5. And if you're not really buying that, we could very easily verify that this stuff is true. Remember, we are claiming that this is a set of all the numbers that make the original true. If we do not flip it, if we actually kept the direction of the original, if we actually said greater than stays greater than, then this would tell us we could pick any number that's greater than negative 20, and it should make the original one true. Well, let's just pick a number that's greater than negative 20. Here's a really easy one. Pick 0. 0 is farther right on the number line. 0 is greater than negative 20. So if we actually pick 0 and plug it back in for the original, 0 divided by negative 4 is greater than 5. We would be making the claim that this is true. Well, of course, 0 divided by negative 4 is actually 0. And so we're making the claim that 0 is greater than 5. And that's not accurate. That just does, it's not true. However, if we took our original inequality and we flipped the direction from greater than, flipped to less than, 0 less than 5 actually is true. This shows us that when we divided by a negative, we need to flip our inequality. Greater than gets flipped to less than. Similarly, less than or equal to gets flipped to greater than or equal to. Well, why didn't we have to flip it here? Why didn't we have to flip it when we multiplied by a positive 4? Well, just like before, we could pick something and show that it wasn't needed. If we're looking at saying 20 is greater than, t is greater than 20 is our answer, then pick a number that's bigger than 20. For instance, 28. 28 is larger than 20, so we'll put that in. 28 divided by 4 is greater than 5. 28 divided by 4 is 7. 7 is greater than 5, and we can see that it actually is true. We don't flip it because we don't run into the problem. The only time we run into a problem is when we multiply or divide by negatives. You'll never encounter that problem with any kind of addition, any kind of subtraction, or if you multiply or divide by positives, we'll be okay. So what do you think about this one? Well, if you remember our last video, we commented that we want to have variables on the left. It's easier to interpret it, it's easier to understand, and we have a choice. We can choose to solve it the way it is right now and flip it at the end after we've got our solution, or we can flip the beginning problem. My preference is to flip the beginning problem. Just the way my brain works, the way my brain is wired, this is what makes better sense for me. Not everybody agrees with me. Some people like to just go through with the original problem and flip it at the end. And if you're one of those people, go ahead. There's nothing wrong with doing it. I'm just picking a strategy that clicks with my brain. When I look at it this way, I can recognize then more easily that I have times 2. And so to undo multiplying by 2, I know that I need to divide by 2. And in particular, I want to make an observation. I am dividing by a positive 2, not a negative 2. Because I'm moving over a positive 2, I will not flip the inequality. I'll still do my number crunching. Negative 10 divided by positive 2 gives me negative 5, and right there I have my solution. One thing that you should be careful about, once in a while students make the mistake of thinking because the 10 is a negative number, they are supposed to flip. Make sure that you don't make that mistake. The number over here, it would not matter if this were a positive 10 or a negative 10. That number is not important. The important number in determining is right here. We were dividing by a positive 2. Dividing by a positive. Because the 2 was positive, that's what tells us don't flip the inequality. However, here, we've got our multiplication with negative 5 times z. We know that we will need to divide. And I wanted this to be in a darker color here. So divide by negative 5. They'll cancel each other out. It's not inverses. But this is one that since we divided by a negative, we will need to flip the inequality. Negative 15 divided by negative 3, negative 15 divided by negative 5 equals positive 3. And so right there we go. We have our solution set. Z is greater than or equal to 3. And now here's our last example for the day. While you are training for a triathlon, you try to eat 2,400 calories a day or more, at least 2,400 calories. Well, for your high carb, your high carbohydrate dinner, you like to eat at least 700 calories. Since each cup of pasta has 200 calories, how many cups of pasta would you need to eat at dinner? Let's start looking for relationships. What is it that you're actually trying to determine? We're trying to determine how many cups of pasta. Well, other related information, each cup of pasta has 200 calories. So what we're noting is 1 cup is 200, 2 cups, 200 times 2 would be 400 calories, 3 cups, 200 times 3, we would recognize that the number of calories per cup multiplied by the number of cups is going to equal the total amount of calories you're consuming. This type of relationship we should recognize as taking 200 calories multiplied by the number of cups you eat, and that's going to equal the calories that you have at dinner. Well, we were told You like to eat at least 700 calories, so at least would tell us something less than greater than. Which one? At least would tell us greater than, and not only is it greater than, it's greater than or equal to. When you read through this problem, all of these clues are here so that we can recognize this relationship. When we wish to solve it then, we could very quickly just divide by 200, which tells us then 700 divided by 200, that's 3.5. You would need to eat at least 3.5 cups, 3.5 cups of pasta for your dinner. One other piece I wanted to note, what about 2400? 2400 was just extraneous information. It wasn't actually necessary information. When you work through word problems, you will occasionally encounter problems that have extra information, and they're there so that you can to check if you can discern between relevant and irrelevant information. For the thing that we were actually searching for, the number of cups of pasta that you eat at dinner, the total amount of calories you have for the whole day wasn't relevant in this specific context to what the calories you eat with your pasta dinner. Now we'll note, we finished everything that we would need to do. Recognizing relationships, building the inequalities is of course a very critical skill. They're also based on your ability to multiply and divide to solve inequalities. Please remember though, if you multiply or if you divide by a negative, those are the only times when you flip the inequality.